Hello everyone, so I wanted to go over a position velocity acceleration problem with you guys. So in number 5, this is not calculator active. No calculator allowed here. Okay, and so as we go over some of these parts, these are some of the things that, of course, relate with position velocity and acceleration. But what will be helpful is for you guys to kind of refer back to that review guide fill in the blank thing that I had made for you guys for units 1 through 4, and then for 5 through 8. Okay. So, it says two particles move along the x-axis. For t is in between 0 and 8, the position of particle p at time t is given by this. So the position of particle p, right? Sorry, that was kind of a weird highlighter. The position of particle p is this function here. And this is from 0 to 8. And then it says the velocity of particle q is given by this function. And then it says particle q is at position x equals 5 at t equals 0. Okay. So VQ, oh, sorry. I should say XQ of 0 equals 5. Okay, so that's kind of what that part means there. So x sub q of 0, that's representing the position of particle q at 0. So yeah, don't get too thrown off by this like subscripts that they're using. It's just to distinguish between, particle p and particle q. Okay, so it says from 0 to 8, when is the particle p moving to the left? Okay, so in other words, it's asking when the velocity of particle p is less than 0, right? Because remember, velocity is speed with direction. So if you want to know in what direction you're moving, you got to look at the velocity function, right? And so if it's negative, it's moving down or left. If it's positive, it's moving up or right. Okay. So I don't have the velocity of particle p yet, but I do have the position function. So you want to recall that for the velocity function, I know that's equal to the derivative of the position function, right? And so remember, it is important that you actually show this out, like that link between the velocity and the derivative. Okay, and now we want to actually find the derivative of this function, so we got to use chain rule, because it's the derivative of ln of stuff is 1 over the stuff times the derivative of the stuff. And then times the derivative of the bottom, which is 2t minus 2. So I'm getting 2t minus 2 all over t squared minus 2t plus 10. Okay. So if I want to figure out when this is, bigger than 0, right? I can use the same idea that I use for local maxes and mins, where I figure out where it's equal to 0 and then make a number line and test values, in between to see where it's positive or negative. So you'll want to note here that VP of t is equal to 0 when t equals 1, because you would set, well, I'll back up a second. So you would set t minus 2, equals 0. So you'd set this equal to 0, which just implies that this is when the top is equal to 0. And then when you solve this equation, you should get t equals 1. So the velocity is equal to 0 when t equals 1. So now we want to make a number line here from 0 to 8. And then we have 1 on it. I'm going from 0 to 8 because it said from 0 to 8, right? And now I just need to plug in a number in between 0 and 1 into the velocity function, and then something in between 1 and 8. So VP of 1/2 is equal to 2 times 1/2 minus 2 over 1/2 squared minus 2 times 1/2 plus 10. So I'm only really interested if this is going to be a positive or a negative. So it looks like the top will be negative and the bottom will be positive. So a negative divided by a positive is a negative. So this is less than 0. And then now I'm going to plug in 2. So I get 2 minus 2 over 2 squared minus 2 times 2 plus 10. So this is definitely going to be positive, so I should get a plus here. So we know that the particle P is moving to the left from 0 to 1. So particle P left 4 zeros less than or equal to T is less than 1. Since the velocity is negative, okay. So that's where we would get the particles moving to the left. So now with B, it says find all times t during which the two particles travel in the same direction. So I'm going to have to figure out then for what times VQ of t is, positive or negative. Well, traveling from left to right. In other words, where is the velocity going to be positive or negative for the particle Q? Since I already have the velocity function, I really just have to set this one equal to 0, solve for t, and then make a number line for this one. Okay, so in part B, we would have VQ of t is equal to t squared minus 8t plus 15. So t squared minus 8t plus 15 equals 0. And then we can factor this. So VQ of t is equal to 0 when t is equal to 3 and 5. And then we make a number line. So 0, 3, 5, and 8. And plugging in values in between here, we should get that this one is going to be positive, negative, positive. So we want to see where this overlaps. So kind of going back to this other number line here. Let's see, when does it look like they have the same direction? So it looks like they're moving in the same direction from 1 to 3, and then from 5 to 8. So Q and P are moving in the same direction for from 1 to 3 and 5 to 8, since VP of t and VQ of t have the same sign. Okay, so yeah, so that would be our first two parts. And then, yeah, I think you would technically include 8, because I guess you would still be positive strictly on 8 for both of these. But anyways, so for C, I think C is probably the most typical question. It says, find the acceleration of particle q at time equals 2. And then it says, is the speed of the particle q increasing, decreasing, or neither at 2? So when the speed is increasing or decreasing, you need to check the velocity and acceleration. And if they have the same sign, it's increasing, it's speeding up. And then if they have opposite signs, it's slowing down. Okay, so the opposite here. All right, so let's find the acceleration of, particle q. So that'd be the derivative of the velocity. So we go down to C, and we have the acceleration at q of t is the derivative, q at t, which when you take the derivative of that function, you should get 2t minus 8. So, and then it asked at what value was it again? At 2, right? So the acceleration at 2 is equal to 2 times 2 minus 8, which is -4. So that's negative. And then the velocity at 2 what was the function again? Minus 8 times 2. Yeah, so this is going to be positive. So the speed is decreasing. Since AQ2 and VQ of 2 have opposite signs. Okay, so yeah, so I hope that kind of helped you guys in terms of parts A through C. So now it says, find the position of the particle q the first time it changes direction. Okay, so when does the particle q even first change direction? Well, we already kind of figured out when, it's what direction it's even going into from 0 to 8. So it looks like the first time q changes direction is at 3, right? It changes from positive to negative at 3, so that means it changes from going to the right to now going to the left. So I want to know the position for particle q at t equals 3. So I want to know what x cubed of 3 is. That's the question. Okay. So if you recall back, we actually were given an initial condition. We were given the position of particle Q at 0, right? So just like we did, before, where we were thinking about FTC yesterday, now we're going to think about FTC again, because we have the initial plus the integral will give us our value here. So if I find, so D, to get 3, I'm going to do the initial plus the integral from 0 to 3 of the velocity function, because that's the derivative of the position function. So really it's just coming from FTC. And so this would give us 5 plus the integral from 0 to 3 of t squared minus 8t plus 15. And then now I just have to compute this definite integral. So this would be t cubed over 3 minus 8t squared over 2 plus 15t from 0 to 3. And then I just need to plug in the values. I wouldn't simplify it because you'll get your answer. So plus 3 cubed over 3 minus 8 3 squared over 2 plus 15 is 3 minus, and then 0 cubed 3 minus 8 0 squared 2 plus 15 times 0. All right. And then if you did simplify it, I guess you should get 23. But I'm not going to bother simplifying it, so you should just leave it like that.